Hey everyone, this is Fernando. I'm going to explain you in this video briefly about Tensorflow, which is a JavaScript library that is used to train and deploy machine learning models. This means that it aims to make a computer able to learn, remember, and predict values that can be later used for a specific application. The music in the background, this is an automated program that creates music based on certain inputs that you give to the program. You can find it in the TensorFlow webpage, so it's tensorflow.org. And well, this is of course a really complex example, so I'm just going to show you a more simple example that I have been working on. So I'm going to explain you about the program that I implemented with TensorFlow. So in this case, we have two characters, so letter T and F. Each one corresponds to 9 values, so it's an image of 3 times 3 pixels, if you can see it like that. And I want to train the computer so that letter T has an output of 1, minus 1, and letter F will have an output of minus 1, 1. This is the architecture of the neural network that we're going to implement. So we have an input X of 9 values in this case, and we'll have a neural layer that will have 2 neurons. Each one of them will have one output, so we're going to have a total of 2 outputs. As we can see here, so we have 2 outputs and 9 inputs. Our code will be like this. So first we want to load the tensorflow.js. Then we can create a model. We can add the layer of neurons that I just explained to you before. So we'll have 2 units, 2 neurons, and an input of 9 values. These 2 tensors that are really similar to an array correspond to both the training set of T and F will be for x1 and x2 respectively. Then we can concatenate with xs. And we can also say that the outputs that we want for each one of them are y1 and y2, and we can concatenate with ys. Then with this command we can train the model, so we can train our neural network. And with this part we can use the model to predict the output of a given input. So we want first to make sure that our original inputs are still have the same output. So we're going to test with our first character, so training set T, and save this, and I'm going to reload this, and it tells us that the result is 1, minus 1, has some decimals, but we can just get rid of them. So it's 1 and minus 1, which is the same value that we wanted, that we trained the computer with. Now we can check for the second value, so that will be x2. We save, and we load this page. Now we get results of minus 0.8 and 0.8. So we're going to put those here, minus 0.8 and 0.8. As you can see, it's also very similar to the outputs that we gave originally. And now we're going to test with these other 2 images that we haven't fed to the neural network. So let's see if the testing is the same values that I think, me as a human, I think that they are. So the first one will be x test t, which I generated in here. So we're going to save this, and let's see what the result is. And so for this example, we get 0.5 and 0.3. So this is 0.5 and 0.3. Now, in this case, we didn't get a negative value, but we can assume that this is the highest value. So we can see that it's actually a bit more similar to the output of the original T than the output of the original F. So yeah, we can say that this was actually letter T. And let's try with the other set of values. So this is test F. We save, and the result is, and so we get values of minus 1 and minus 0.3. So we have minus 1 and minus 0.3. In this case, it's more similar to the output of letter F, because this is a higher negative value, so it's closer to this set of values. So we can say that this also had the output that we wanted. And that's pretty much it. So thanks for watching.